hear me clearly now? And the content is shared?
Yes, it's shared. Thank you.
Okay, let's start. Hello, everyone. Let me first introduce myself. I'm Dr. Mai Sayed, lecturer of endodontics in Bani Suef University and an MBA holder in hospital management from the Arab Academy of Science, Technology, and Maritime Transport. I'm very honored to be with you today in the first International Dental Conference held by the Faculty of Oral and Dental Medicine, Delta University. Thanks for the kind invitation by the Executive Director, Prof. Dr. Hala Hazza, and the efforts made by the whole organizing committee of the conference. Dr. Bean, is still the connection? Can you hear me?
I can hear you, but the presentation is not working.
Okay, let's begin. In today's lecture, we are going to have an overview on anatomical three-dimensional root canal cleaning and shaping that every endodontist seeks and tries to attain during treatment. Let's see if it is possible or not while highlighting on the role of expanding instruments in nickel titanium instrument industry. First, I would like to declare that I don't have any conflict of interest nor financial interest regarding any of the products that are going to be mentioned throughout this presentation. Let's start. Successful endodontic therapy is generally dependent on two main factors. First, the elimination of bacteria from the root canal system and the prevention of reinfection of this cleaned and shaped root canal system. But as we all know, pulse is very complex in its internal anatomy. We may have root canals that may divide, rejoin, in addition to the presence of lateral canals, accessory canals, isthmuses, bifurcations, and severely curved roots. This makes the complete eradication of bacteria a very challenging mission. Three-dimensional root canal space cleaning is what every clinician strives for, and is considered the ideal option, which is to clean the root canal content only in a three-dimensional fashion, without unnecessary removal of sound, healthy dentin. Is it possible? Clinical and product research have focused on concentrating their work in three directions to reach the goal of three-dimensional endodontics by improving the irrigation protocols and techniques, like the use of ultrasonics and laser-assisted irrigation, the creation of new root canal instruments. We all know now the breakthrough in bioceramic nanotechnology, and the creation of new instruments, designs, and alloys. And that's what we are going to address in today's lecture. The innovations made in nickel titanium instruments and how they affect our treatment outcomes. But we all must know that the ultimate goal of the instrumentation phase during endodontic treatment is to create a sterile root canal system before filling, while retaining as much healthy sound tooth structure as possible. So let's have a quick view on the history of endodontic files that we use for this purpose. Let me make sure that you can see my presentation clearly. Dr. Reem.
It's okay, Dr. Mai, we can see you clearly.
Okay. So let's have a quick view on the history of endodontic files that we use for this purpose. Although stencil hand files are still used for patency and glyca purposes, but we can't complete the root canal treatment using these files due to their inherent stiffness that increases as the size of these instruments increases. The large sizes of these files can't easily follow the normal curve of the root canal and can't maintain it throughout the preparation due to the restoring forces that attempt to return these files back to their straight original shape, leading to many procedural errors like ledge formation and apical transportation. That's why the introduction of the nickel titanium rotary files was a major breakthrough that resolved many of the instrumentation challenges presented by the stencil hand files due to the high flexibility, super elasticity, and the ability to maintain the original shape of the curved root canal. There are more than 30 different types and designs of nickel titanium files available in the market today that are categorized into different generations, as we all know. But today, for simplicity, we are going to classify them according to their motion in the canal, how they move inside the canal. First was the conventional nickel titanium files with continuous rotation motion. These files have what we call the symmetric cutting axis. What does that mean? That the file, during rotation, it rotates around a centered axis of rotation. Whatever the geometric design, the files rotate around the center axis of rotation centered inside the file, with all the cutting fluids touching the root canal walls. This design made the file suffered from excessive torque and fatigue, leading to potential deformation and unexpected separation, as we can see here. To reduce the stresses exerted on these files, the reciprocating files were introduced. The main aim was to reduce the surface contact between the instrument and the root canal walls by the reciprocating clockwise and counterclockwise motion. The main drawback of these files was the high percentage of debris accumulation and the apical intrusion of these debris, leading to apical peritonitis and post-operative pain. Then came the eccentric dietoid files. These are file designs that have an asymmetric cutting axis, an offset center of rotation. The axis of rotation is not centered inside the file, as we can see here. When two cutting fluids are touching the root canal wall, the other two are free. This resulted in what we call the swaggering motion, the snake-like motion. The file moves inside the canal like a snake. This first reduced the surface contact of the file with the root canal wall, so reduced the stresses exerted, and created a space that allowed for the easy removal of the generated debris from the root canal during preparation. As you can see here, this is the swaggering motion inside the root canal and the space created inside the root canal for easy removal of the debris. This design for sure enhanced the performance of these files when compared to the previously mentioned type, as we can see here. Still, the major problem of all these files, whatever their cutting motion is, that they all created around the cross-section preparation in the root canal, ignoring the obvious that the root canal is not round. Why will that make a problem? Let's see. We have long known that the majority of human root canals are always in cross-section, mostly in buccolingual dimension. We always teach our students that the majority of the root canals are wider buccolingually than medial-distally. And here is an axial view for a cone beam CT. We can see clearly here that the maxillary canine, the maxillary second premolar, is oval in buccolingual dimension. And here is the mandible, the mandibular incisors, the mandibular canine premolars, and even the distal roots of the mandibular molars are oval in cross-section, in buccolingual dimension. none of them is round. And here come the challenges that we face during root canal instrumentation. That until now, almost all the instruments used for this task, either hand or rotary instruments, with their different geometric designs, have prepared the root canals in a rounded cross-section, leaving when resulting in up to 70% of the root canal space left uncleaned and unprepared. As we can see here, around the cross-section preparation in the oval root canal, around this cross-section preparation in the oval root canal, leaving all these areas unprepared and uncleaned. And ironically, till now, the adequacy of our root canal enlargement and shaping is still clinically judged by the traditional two-dimensional radiographs, although the limitations have long been known. These radiographs only show us the medial-distal perspective of our obturated root canal, ignoring the buccal equal dimension that we often fail to clean effectively during the mapping of the root canal space using microscopy after instrumentation showed that barely 50% of the root canal space is clean, as proved by Paquital in 2010 and again by the DIDC in 2015. As we can see here, the red areas are the areas touched by the instruments rotating inside the root canal, while all these green areas were left unprepared, untouched by the introduced instruments. To make the concept more clear, imagine with me that this is the root canal that is oval in buccolingual dimension. Here is the remaining dentine thickness in the medial-distal perspective, and this is the endodontic file introduced inside the canal to prepare. Any attempt made to increase the size of the file, the rotating file, to clean the buccolingual dimension will eventually lead to weakening of the remaining dentine thickness in the medial-distal perspective. If the size is increased even more, this will eventually lead to perforation in the medial-distal aspect before even reaching or touching the buccolingual dimension of the root canal. To make the problem worse, the cutting action of the rotating instrument generates a large amount of loose debris that get packed in the spaces available in the buccolingual dimension. And believe me, the removal of this packed debris using irrigation is not an easy task at all. Additionally, the cutting action of the file together with this packed debris may result in stresses formation inside the tooth itself, leading to dentine microcrack formation and potential microfractures occurrences. Here is an attempt to increase the size of the file, leading to canal perforation, and we can here see clearly the packed debris in the oval root canal, and see the round cross-section of the made by the introduced file. This is totally inconclusive. And here are the micro cracks formed in dentine after preparation, and here after obturation. And then is the new category of root canal instrumentation system, the expanding nickel titanium instruments. This category includes any file design that have the ability to expand in the canal and adapt to the canal's natural morphology. Today, there are only 3 instruments that fall in this category: the self-adjusting file with the SAS technology, the XP into shaper, and the XP into finisher with the Max wire technology. Let's know a bit about them, their mechanism, and how they work. The self-adjusting file was introduced in 2010 with a very special design. It's a hollow file with no central core, as we can see here. It's highly compressible that can adapt itself in a 3-dimensional manner to the shape and the cross-section of any given root canal system. It is operated in a vibratory in and out motion with continuous irrigation delivered to the root canal through a pump attached to this hollow file. When this file is squeezed in one dimension, it expands in the other dimension, and this works effectively with our root canals. When the file is introduced inside the root canal, it becomes squeezed in the narrow medial-distal dimension of the root canal, as you can see here, and expands in the buccal dimension of the root canal. So cleans and prepares the root canals effectively. According to Medder in 2014, the SAS technology allows for a new concept in root canal cleaning and shaping, which is the minimally invasive three-dimensional endodontic. Through the three-dimensional scraping effect of the file, the preservation of dentine, and the continuous delivery of fresh irrigant throughout the procedure. However, the SAS technology didn't gain popularity due to the need of additional special handpieces to operate this file, and the significant time needed for its successful implementation compared to other nickel titanium files. Then came the XP family, either the XP Endo Shaper or the XP Endo Finisher. Both files adopt what we call the max wire technology. The max wire technology is a heat treatment technology in the nickel titanium alloy from which these files are made from. This alloy has the ability to change its design and properties when subjected to different temperature changes. Let's see how this works. For the XP Endo Shaper, this file has a tip size equivalent to size 30 and only a 1% taper throughout its length. It has a serpentine shape, a wave shape, as we can see here. At room temperature, the file is soft, easily bendable, can be easily introduced inside the root canal. When introduced inside the root canal, the temperature is elevated at body temperature. It becomes stiff enough to cut dentine and expand inside the root canal, with expansion capacity that may create tapers up to 8%, depending on the time that the file operates inside the canal. The 1% taper makes it highly flexible and highly resistant to fatigue and separation. Here are the cross-sectional images at 1, 3, 5, and 7 millimeters from the apex. We can see how clearly and safely the shaper cleans and prepares the root canal while respecting the original root canal anatomy. It also creates a space inside the root canal that allows for the easy removal of the generated debris during preparation and prevents them from being packed inside the irregularities of the root canal. Here are micro-3D images of two root canals with the isthmus portion in between. On the left, the canals were prepared by reciprocating files, the reciproc, and we can see how much debris got packed in this isthmus portion. On the right, the canals were prepared by the shaper, and we can see that barely any debris got packed in this isthmus portion. According to Byron-Mittal in 2017, the concerns about stress creation inside the tooth and dentine microcrack formation almost disappears with the use of the shaper file. Here are plastic blocks with light filters that shows the stress buildup after instrumentation using different nickel titanium files. Up on the left, the reciprocating files created the highest amount of stress buildup, especially in the apical third of the block, followed by the one file system with continuous rotation, and the least stress buildup was found in the XP Endo Shaper group that showed the less stress buildup at the apical third. What about the XP Endo Finisher? The XP Endo Finisher adopts the max wire technology as the XP Endo Shaper. It has a tip size equivalent to size 25 and a 0% taper throughout its length. At room temperature, it has a straight shape, as we can see here. When inserted inside the canal at body temperature, it acquires its unique spoon shape at the last 10 millimeter of the file, with a depth of 1.5 millimeter. Upon spinning inside the root canal, it becomes highly flexible, that expands up to 3 millimeter inside the major diameter, the buccolingual diameter of the root canal. The 0% taper makes it highly flexible and highly resistant to fatigue and separation. It causes turbulence of the irrigant inside the root canal that enhances the antibacterial efficacy of these irrigants and disinfection of the root canal. It can be used, has a universal use, can be used after any instrumentation system made by any manufacturer to complete the preparation, reaching up and breaking debris and smear layers and reaching areas and spaces that wasn't cleaned and reached by the conventional instrumentation method. So we can use that. So we can say that it completes the incomplete job of typically touching all the root canal walls and surfaces. Research indicates that the XP in the finisher is particularly beneficial in the ecosystem of the root canal and is highly effective in removing the debris and smear layer from the root canal, the eradication of bacteria from the main canal, and up to 40 microns inside the root canal. See how much depth of penetration and effect of the XP in the finisher? The clinical use of XP in the finisher is best visualized in clinical cases that may have irregular root canal anatomy, like immature teeth with blunderbuss apices, teeth with ribbon-shaped cross-section, and with teeth with internal resorptive defects, as we can see here in this maxillary lateral incisor. The XP in the finisher is very effective in completing the preparation of such cases, as we can see. Once the root canal is cleaned and shaped at its best, we can proceed with the obturation phase using the conventional method. However, the best to be used in such cases is the bioceramic sealer. With a gastric cone, the cone acts as a carrier for the sealer, a space keeper for further retreatment if needed. Thanks to the physical and the chemical properties of the bioceramic sealer that can adapt and seal all the anatomical spaces in the oval root canal that even Getaperca can't reach with warm compaction methods. And that's what we call the three-dimensional anatomical obturation. To wrap this up, in conclusion, recent advancements in nickel titanium technology and ceramic nanotechnology are permitting clinicians to embrace a more minimally invasive technique for endodontic debridement that combine both anatomic shaping and safe instrumentation, resulting in more predictable outcomes. Thanks to the anatomical expanding nickel titanium instrumentation system that allows for three-dimensional adaptation to the root canal natural anatomy, more conservative preparation, especially in the dangerous zones, less debris accumulation and packing, high resistance to fatigue and separation, and moreover the concerns about stress creation and dentin micro crack formation inside the tooth disappears with the use of these systems. Still, clinical experience and research teach us that there is not yet a perfect method, nor a universal instrument to perform endodontic treatment and allows us to perfectly heal the root canal. Recent achievements have certainly allowed us to move forward in order to reduce the risk of failure and increase percentages of healing. We will certainly need further studies to confirm the efficacy of these new alloys and the various shaping methods. Thank you very much for your attention and time, and I'm very happy to be with you today. Thank you very much.
Thank you, Dr. Mai Sayed, lecturer of Physics, Faculty of Benicwest University, for brief lecture and for introducing participation content.
Let me open the chat to see if there is any questions.
There is one question asking about the irrigation liquid.
The irrigation use, we will use sodium hypochlorite at 2.5%, 2 millimeter between instruments during the preparation phase. And then we will have a final flush irrigation at the end of the preparation. We will concentrate on the volume, on the time, and on the concentration. Concentration, we will use 2.5% sodium hypochlorite, 2 millimeter, and activate it with, if we are going to use the XP in the finisher, for example, for activation, we will activate it for 30 seconds. And then replenish these areas irrigant again with 2 millimeter of 2.5% sodium hypochlorite and activate it again with for 30 seconds. Then the use of editor activation, then washing with distilled water. If there is a chronic infection, persistent infection, we can add chlorhexidine at the end for the antibiotic effect.
Thank you, Dr. Mai Sayed. Lecture of endodontic at Wake University. Today's lecture. Can you hear me, Dr. Mai?
Yes, I hear you. Sorry for the video issues. Totally
Any further questions?
I think that the video is going to get back now.
No worries.
I'll be very glad to have any questions with you, of course.
No questions, I think.
Okay, thank you, Dr. Reem. Thank you for your effort, and thanks for the effort of the organizing committee. It was a pleasure being with you today.
Our pleasure.
Thanks, Doctor.
Now we've come to the end of the first session for today, the third and the final day of the International Dental Conference held in 16th to 18th September 2020. I would like to thank the speakers, Dr. Mai Sayed, Dr. Asma Harbash, and Dr. Mai Sayed. We hope you will see you again in upcoming events. I also want to thank Professor Dr. Mohammed, the contributor of the conference, Dr. Hala Hazan, the director of the conference, and all the audience and students. Now, with a break, and we will proceed to the second session for today, the orthodontic and subject session, 30 p.m. Thank you. See you again. Goodbye.
Bye.